Good morning. My name is Ryan Lynch. This summer marks my 22nd year in the crane industry. I have been involved in crane operations, both big and small. I've run everything from a 5-ton carry deck crane all the way up to a 550-ton truck crane. My experience covers the board, everything from high-rise construction to plant equipment, right down to underground vaults. Today I'll be talking about lift planning and reading a range diagram. The first thing to know when planning a lift is be thoroughly prepared before making or attempting any type of lift in a crane. Determine the boom capacity limitations, including length of boom, capacity at different radii, size of load, angle of boom need to be taken into consideration also. Crane capacities are based on 3 factors: the machine weight, machine stability, and strength of all components associated with the crane. The main factors which affect the lift of a load are the weight of the load, shape of the load, center of gravity of the load, height to which the load is raised, and the final position of the load. Load radiuses will always increase once the load is lifted off the ground. The inherent nature of cranes cause boom deflection. It does not matter what size or what capacity of machine it is, there will always be some boom deflection. On critical lifts, the radius should be remeasured after the load is slightly raised to make sure you have not fallen out of your charts. Careful attention must be paid to the range in which the load radius falls. The operator must know the difference between the rated capacity of a crane in regards to strength and stability. The operator's responsibility. Everyone involved in the movement of a load, especially the operator, must be aware of the consequences of poor lift planning. The operator must understand all aspects of the machine, including control location and movements, crane movements, capacities, load charts, range diagrams, and any other related data. The operational speeds, audible and visual signals. Now, these can come from a dedicated signalman using hand signals, radios, or a combination of both. The operator must have a basic knowledge of crane inspection to identify any structural, hoist, drivetrain damage or problems. Now, most operators can look over a machine from top to bottom and understand the basics, but an experienced operator will know exactly what areas to look for and any problems that may arise. Next, we'll talk about critical lifts. Critical lifts are those where the weight of the load to be lifted is close to the rated capacity of the crane. When lifting load weights heavier than 75% of the rated capacity, it is recommended that the following precautions be taken. The supporting surface must be stable. The ground must be in good condition. If you're not sitting on a known thickness concrete pad, you have to do your research. There could be underground tunnels, there could be recent excavations. Any of those will severely affect the capacity of the crane in the lift. Always use blocking to support underneath your outrigger pads and crawler frames. The machine must be level. 1 degree out of level can severely affect the crane's capacity. You must also know the load weight exactly. Any variation there can be detrimental to the safety of the lift. The center of gravity, the location of the load center must be determined, as well as the crane. The load radius must be measured exactly. This sometimes will not be available to you. This is where load charts and range diagrams can help assist in finding the exact load radius. Boom length. The boom length must be determined exactly. In a crawler type crane, this is easy to determine just by merely counting sections of boom. But in a rough terrain or truck type setting where variable lengths of boom can be available, you have to know exactly, and you cannot count on the computer to always give you the best reading. The next is boom angle. The boom angle has to be determined. All cranes are equipped with a boom angle indicator, but secondary measurements used in range diagrams and load charts must be used to determine if it's accurate. Wind is a huge factor, in considering lifts, especially critical lifts. A 10,000 pound load the size of a cardboard box is differently affected than a 10,000 pound load the size of a billboard. The rigging must be checked for safety and security. The weight of the rigging must be known exactly. All rigging must be inspected directly before making any lifts. The operation of the machine is the last and most important factor of a critical lift. An operator must know that machine backwards and forwards. Know all the controls, the speed at which the machine can move, and any other situations that may arise. During the lift, all movements must be made slowly and smoothly as possible. First, we'll talk about range diagrams. All mobile cranes include a range diagram as part of the load chart rating information. The range diagram is a profile or side view of the crane with its full range of configurations. The range diagram illustrates the following information about a particular crane required to plan a lift and placement activities. The range diagram will allow you to accurately represent the crane lift you are about to do by knowing exactly where the load radius is, the boom length, the boom angle, load radius, jib and jib offset, and load heights. Each range diagram is a grid of lines with associated arcs that represent the crane's full range of movement in all different configurations. Horizontal lines represent the tip height, vertical lines will represent the load radius, and two sets of radial arc lines will determine boom angle and boom tip. Boom and jib radial arc trace the position of the boom as the boom and jib angle changes. Range diagrams are some of the most important sources of information available to the crane operator and serve three functions: the geometry of the job, the maximum hook height determination, and verify minimum allowable clearances between boom tip and load blocks. Range diagrams may also be the only source to determine the load radius from boom angle indications. Many times the actual radiuses cannot be measured effectively. Therefore, you must refer back to load charts and range diagrams to know for sure. Range diagrams can be used to identify the minimum allowable clearances between load blocks and boom tip. Next, we'll talk about the center of gravity of any object. The center of gravity of any object is the point in the object where the weight can be assumed to be concentrated. Stated another way, it is the points of the object around which the weight is evenly distributed. If you could put a support under that point, you could balance the object directly on that point. Cranes are capacity rated in various quadrants. Truck type cranes' center of gravity can vary greatly depending on the influence of the carrier weight forward. When lifting over the rear, the effective weight of the carrier forward of the outriggers enhances the crane leverage. When lifting over the front operation, the effective weight of the carrier forward of the outriggers increases the load leverage and decreases stability. In an over the side operation, the center of gravity leverage is less than over the rear operation. Rough terrain cranes are also influenced by their quadrant operations. Most load charts are based on a 360-degree capacity and may have a strictly over the front chart, mainly in an on-rubber situation. Crawler cranes normally operate in a 360-degree sweep due to the upper works mounted in the center of the car body. The crane is rated for a load capacity value at a point where the tipping axis is closest to the center of gravity. Next, we'll talk about gross and net loads. Gross loads is the sum of all weights, the load to be lifted, attachment, rigging, lift points, ropes, etc. Net load is the effective weight of the lift. The capacities listed in the load chart are not the loads that can be suspended from the crane hooks. Those are gross capacities. The max load that can be safely lifted, net load, has to be mathematically determined. And last but not least, let's talk about static and dynamic loads. A static load is the weight of the gross load when the load is perfectly stationary. A dynamic load is caused by a sudden change in the speed of the lift and attachment, such as sudden stopping, snatching of the loads, swing out, and wind deflection. And in conclusion, I'd like to thank you for your time. My name is Ryan Lynch, and I hope to see you soon.
You only did 10 minutes.
That's fine.
That's all you needed?
Are you stopping it?